Hello, everyone. Welcome to the Artificial Intelligence Machine Learning Series episode organized by Advancing Women in Product Boston chapter. My name is Anjali Munjal. I'm a product manager at Dell and a volunteer for AWIP chapter as the head of programming. This is our very first episode in Artificial Intelligence Machine Learning series, and we are very fortunate to have Dr. Subrata Das with us to talk about it. Before we start, I would like to thank you everyone, all the participants today for joining us for this session. A quick agenda that I've for today. We'll start with a short overview of AWIP, followed by the main session presented by Dr. Subrata Das. We'll have a question and answer session towards the end, moderated by Jaira. Jaira is a core member of AWIP Boston chapter. For all the participants, I would request you to enter your questions in the Q&A chat window towards the bottom of your screen, and then Jaira would be moderating the session. Advancing Women in Product is a nonprofit organization that empowers women and underrepresented minorities to advance their careers and growth in the highest levels of tech leadership. Our vision is to strive to help solve problems for the women as well as other groups by facilitating equal access to skill-based workshops and executive mentorship. We founded AWIP in year 2017, and we are proud to say that we have over 12,700 members today. We have several chapters throughout the globe. It started with San Francisco chapter. Now we have New York, Boston, Seattle, Paris, and most recently, the India chapter. In order to stay tuned for all the episodes in the AI/ML series, which will be coming in the future months, I would strongly encourage the participants to register yourself by joining us at www.advancingwomeninproduct.org. A quick introduction for our honorable speaker today, Dr. Subrata Das. He's a consulting chief data scientist at Advent Health, as well as a part-time faculty member at Northeastern University. Dr. Das has a wealth of experience in the artificial intelligence space. He has a PhD in the artificial intelligence and databases, and also has a postdoctorate in artificial intelligence. He has published several books in the area of artificial intelligence, machine learning, and analytics. And we are very pleased to have him here with us to present the NPL series. So without further ado, I'll hand over to you, Dr. Subrata Das.
Thank you. Let me share my screen. All right. Can you see my screen?
Yes.
Okay, cool. So go to the presentation mode, then display setting. Good? Good to go?
Yes, thank you.
All right. So good sunny afternoon from Boston, everyone, wherever you are. Stay safe. And before I start, I'd like to thank Advancing Women in Product, especially the organizing team that includes Bindu, Priyanka, Yaira, Anjali, and Joel. Thank you all. And the topic is natural language processing. I'll focus on both the state-of-the-art technology and business applications. So here is the outline. So I will first introduce AI and ML in brief and text analytics in that context. And then I'll introduce NLP and core functionalities of NLP. And then one specific aspect of NLP is document classification, important aspect that I'll talk about, and then focus on deep learning and NLP, and then business applications and demos. Given this, I must say one thing though, that NLP I always view as an outgrowth of computational NLP, as an outgrowth of the field of AI and ML. So it's important to know what's out there for AI and ML, because a lot of the times the techniques are being reused. And in this particular presentations, I have a lot of slides. I'm not hoping to cover everything in 45 minutes, but I'll skim through some of those, but focus on certain ones that are relevant to this particular group. And it's, as I understand, there are more than 200 registered. So I'm assuming it will be a very diverse background. So I'll focus on like, what are the core capabilities of NLP, what we can do in terms of, having, or extracting insights from business applications. Yeah. That's, primarily the focus. And one of the terms, obviously, we always hear is that analytics that leverage data in a particular functional process to enable context-specific insights. So that's analytics in general, and text analytics is obviously, leveraging textual data in addition to, all the structured data that is out there. And NLP is really an enabler. NLP enables computer to derive meaning from human or natural language input. With that, so very briefly, what are AI and ML? AI system are computer system exhibiting some form of human intelligence. And especially in understanding NL in this particular context, that will pass so-called Turing test. Yeah. And machine learning is an offshoot of the field of AI, and that started in 1950s. And then, machine learning is really have the ability to learn from real world observations. And that's what it is. So what we basically do, the overall process, 64,000 feet view, is that you have data, real world data, and then machines somehow extract patterns, those patterns that constitute the model. Model means model of the real world, so that we can use that model to predict. And model in the context of text analytics could be, language model, for example. So basically, we're trying to learn model that will, reflect the real world, so that we can use to predict things. So just very briefly, again, AI in stages. The first wave of AI was in 60s and 80s. 60s started in really late 50s and 60s, and throughout until 80s, really. Symbolic logic was dominating. Yeah, so everything was rule-based, and some neural net was coming in. As you see on the right of the screen, it's all the various types of rules, in different strengths. And then it didn't go very far, because people in early 80s, they thought that they can conquer the world with just a bunch of rules, but it didn't happen. And that is attributed to the knowledge acquisition bottleneck, because everything you wanted to build required lots of knowledge. So you couldn't really build it, because it required a lot of time sitting with the experts. So then 90s and even until today is really emphasis on machine and deep learning, where you automatically extract knowledge from data, from observations. And so the third wave, we're still kind of third wave is the third wave is really on the collaborative and human machine and hybrid modeling, natural language understanding. Those are the emphasis currently. And explainable and generative modeling, DARPA is spending, defense agencies spending a lot of money on that. So that's very high-level view of AI in AI's history. And as some of you, I'm not going to cover all the techniques today, but most of you are in the field of ML, know that there is a jungle out there. There's a bunch of, huge number of techniques out there, machine learning, and obviously nowadays a lot of deep learning. And it's never, analytics, which is, which exploits machine learning and NLP. It's never really a single universal method. It's always about a bag of tricks. So you got to know lots of techniques, and those techniques are applicable under different areas. So there is really no universal way. So I just wanted to give you a flavor, what is out there. There are hundreds of techniques, literally. And my own evolution, in fact, started, I wrote a bunch of books, but one on the left was published by MIT Press in 2003. If you skim through the book, you will see lots of logic and rules and stuff like that. And then on the right, which was published in 2014, and it's all about machine learning and approaches really through probabilistic probability and statistics. So that you see that there's transition from more symbolic rule-based to probabilistic machine learning. And actually, in reality, it is really a hybrid always. Hybridization is the key. That, as I was telling you, that there's no single technique that can conquer the whole world. So it's always a bag of tricks. And in that context, hybridization, hybridizing rules with probabilistic techniques are the keys. And of course, the text analytics, which we are going to focus today. And analytics, very briefly, because you hear a lot, and they're all on the very similar context. Analytics is a process, and AI and ML and NLP and deep learning, those are enabler. So as you see that, there are various stages: data preparation, descriptive, predictive, and prescriptive analytics, and towards the automation, and text analytics is somewhere sitting there. And it, what we always see, most of the time see, is that people are dealing with lots of structured data. And nowadays, obviously, you see a lot of image processing, but textual data is everywhere. So, there people are now incorporating textual data into their processes so that additional insights that can be gained. And as you all know, that more than 80% of the time we really spend on the bottom left corner here, which is the data preparation. But that's a different story. So quickly, what is structured data versus unstructured data? So structured data is computerized, information which can be easily interpreted by and used by a computer program, because the stuff you see in Excel or in database tables, those are structured because they are well-defined columns. They have very defined meanings, and then you have a relation, and you have a bunch of values in a row that are in that particular relation. But information stored in relational database, as I was saying, that they are very structured. But texts and images are really considered unstructured data. And audios and videos as well. And so it is, so what is it that we need to do? So if we can structure all the information, like given that if you have text or images, if we can structuring means what? That given a piece of text, can we extract all the information that are in it and represent it in the form of relation, or in Excel, or in relational table? If we can do that, then obviously we are golden, but it is not that easy. And that is why the talk is today, like what are the challenges? But if you see here that an image is really very expressive, and then you also have, you can describe the same image with some text, and then you can describe the same image using some kind of relations if you have well-defined columns in that particular relation. So here, as you see, as you go towards left, it is increasingly suitable for human consumption. And then as you go towards right, it's increasingly suitable for machine processing. So you see here, text is Homer is sitting on a chair drinking beer. And I can say the same thing using Homer is drinking beer while sitting on a chair, and the same semantic content, but in different representation. And then once you look at the image, you can infer even a lot more things, that the beer is dripping out of his bottle. There are things lying here and there. So there are a lot more things you can infer, which is not in the text, but you can represent in the text. But text means, once you have a piece of text, there are lots of relations. There's no well-defined single relations, there are multiple relations. But in this case, you can have relations in the form of, for example, action, person, object. So sitting and drinking could be relations, and who is sitting and on where, and who is drinking what, that kind of thing, yeah. But one thing for sure, although a piece of text may represent lots of relations, but one thing for sure, that because the piece of text is also, there are some grammars in it, and there are some sentence means there are multiple clauses, so you can always derive at least subject, verb, and object, okay? So even if you do that, then at least you have structured in some way. So that's what it is. And then obviously, when you go to audio and video, then things obviously are much more difficult, because you have discourses, you have how you represent discourse. So we are really barely scratching the surface in terms of fully understanding all those unstructured data that are in text, images, and audios and videos. So why NL structuring is difficult? Because there are so many ambiguities, yeah? So I've given some examples here. Syntactic parsing and semantics ambiguities is, there's a lady on the mountain with an umbrella. So with an umbrella modifies the lady or the mountain, yeah? So there are a bunch of examples here. I booked my flight from Boston, and it's a from Boston modifies verb flight or noun Boston. And then you can also have like, this is another form of ambiguity, is they're visiting relatives. Visiting is a verb or adjective. So there are many, 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 many more. And then metaphor is another thing, is that her words are music to my ears. It's literal, it's not a literal meaning, right? Music to my ears is makes me feel happy. So the meaning is very different in the context. So context analysis of the context. It's not only the parsing of the sentences and analyzing the sentence, but also taking into account the context is also very important. And then the named entities, for example, Washington played really well in that crisis situation, whether Washington is actor or an organization, really. So those are some of the ambiguities that you always come across. But we human, we can process, pretty easily, because we assimilate the context very, very easily in our brain. So these are really some real world challenges. In fact, most of them I've been working with. In fact, most of the areas I've been working with. So I've taken some examples. And I think I spent a minute here to understand what are the different areas that we can work on. So one of the things is that we come across as a review is, so when a customer writes a review, a manufacturer or a service provider would be very interested to know what are the things they're talking about, good and bad. The good things can be used for publicity. Bad things can be used to improve upon. So in this case, for example, anti-infestation, talking about the bed, stuff like that. And then in a typical care providing situation, when nurse or doctor is talking over the phone or via chat, they're talking about the symptoms, and in this case, in fact, you see that they're talking about the symptoms, they're worried about the travel, that kind of stuff. And then in call center agent, so if the human, or it could be human or chatbot. So anyway, the point is that what are they complaining about? What are the different questions they're asking? And things like that. So for example, here color is so incredibly off. So they're complaining about something. Yeah. And then one of the other applications you always come across, I mean, in fact, we've been doing a very good job in terms of classifying spam from the real email. And in fact, if you see your email, there are hardly any spams that go through, and you don't know there's a lot of things going behind. And those, in fact, I'll give a demo in that for that particular area. And then also, media report, and people are talking. There's so many publications are out there, and people are talking, so extracting those information and structuring. So these are some of the areas, like recognize named entities, for example, person and symptom names, understand types of complaints and questions asked, extracting detailed relations. For example, White House briefing, if you want to find out who gave briefing, when, where, on what, those kind of things. So you have to have extract the information from that kind of, reported piece of text. Then one of the things we always do is search messages by understanding intent in user queries as opposed to only keywords. So when you give, when you search, when you go to Google, they do a lot more than just, going through the keywords. So, they try to understand the intent. What are you trying to say? They take into account your background as well as sometimes what you have searched before, and then answer customers in a chatbot by understanding user questions. So those are some of the real world challenges, really. And in fact, these are the examples I've given because I've worked in many of these areas. And now we are, with that introduction, now I'm going into the NLP and core functionalities. And I tried to capture in one slide, what does it involve in processing some, pieces of text, yeah? So there's two stages, is a syntactic analysis and semantic analysis and structuring. So from the syntactic analysis, as you know, some of you know that, tokenization, morphological analysis, parts of speech tagging and syntactic parsing, they come in sequence. So whatever you do at least, for every application, you do at least tokenization, yeah, that for sure, yeah. And then you do, depending on the applications you have, you go through along these flow. And then you also have named entity extraction, then coreference resolution. I'll give you examples of each of these, and then the relation extraction. And once you have extracted relation, at least you have some structure on your text, and then you can do a lot of things on those, okay? And as you see here, these are really core functionalities at the bottom, okay? Because you build your business application based on these core functionalities. So, for example, if I say sentiment analysis, it's a core functionality. That's the way I view it. And then you can understand sentiment of customer or patient or whoever you want. Yeah, you can apply that. The search is a very generic functionality. So at least, for these, you need to do at least, tokenization, and then document classification, you need to do a little bit more than tokenization. You have to do morphological analysis, stemming, lemmatization, and topic extraction, and document classifications are usually done on stemmed documents. And then you can do, syntactic POS, parts of speech tagging, and then syntactic parsing, and those are, if you want to do machine translation, you need to do, those things before. Then you have social network analysis. If you want to do social network analysis, who is connected to whom, then you need to recognize named entities. Yeah. So those are, and you also need to do coreference resolution as well. And then, there are other applications like document summarization, natural language query to SQL. And for those who are, you got to extract the relations. So this is kind of flow of NLP, and then, but there are lots of things, as you will see in the area of computational NLP. Lots of things you can do just by tokenizing, and then by word association, by counting words, by frequency, putting the frequencies in a statistical distributions, So there's a lot of things you can do even without doing deep semantic analysis of a piece of text. Yeah. So let's go through some of these steps. Okay. So I'll go through very quickly. I'll give some examples, and then I'll give you the demo of the first part, and then the next part will be document classification, and then I'll give the demo as well. So tokenization is I'm going to go through very quickly, is as you know, that he got the job in spite of not having all the necessary qualification. You tokenize, sometimes it's split by space, but you can do a lot more than that. You can do chunking and do a little bit more clever tokenization. But basically you are splitting the sentence into tokens, yeah. And then morphological analysis, lemmaization and stemming are part of it. You understand the morphology, study of relation between word surface forms. And then POS tagging, as we all know, that how do you tag parts of speech? There are 8 or 9 different types, and then you tag them. And then syntactic parsing, you can have a constituent burst parse structure or dependency-based structure. And I'll give some examples actually. So this parsing is parse tree. If your sentence is really grammatically correct, then you can parse, and all the tokens will be at the bottom. As you see that the intermediate nodes are labeled with various noun, verb, pronoun, and etc. etc. So, and then you can actually there are some open tools available that you can go and try, like Stanford parsers. They have an online version. You can go and type in your sentence and you can try those. And then dependency-based parsing is that they parse a sentence into a bunch of dependent clauses. For example, I use these dependencies, to summarize and to summarize a piece of text or to convert a natural language to SQL queries. So depending on the applications, you can use in different ways these dependency relations. But basically, you get a piece of text, you get a bunch of dependency relations, for example, subjects and objects, who is subject. So there's a governor and there's a dependent. So it's basically, it's a binary relationship. And then again, you can try those, and you can go online and try your own sentences. A semantic analysis, there are 3 parts of it: is named entity recognition, coreference resolution, and semantic relation extraction. As I was telling you, that named entity extraction is not always that straightforward, in fact, because names can be used because the same, like the example I gave you, like the Washington, for example, it could name a place, name a person, and it's also not only that, a same name is referred in multiple different ways and different types of named entities. So a place, you have organization, and in fact, the date, in fact, you can write in 100 different ways the date. So these are not, it's not easy to recognize and extract named entities from a piece of text, okay? So you have to, there are approaches, obviously. You can have lexicon-based, you can do, you can make use of libraries. There are obviously machine learning approaches. And let me, and then coreference resolution is another thing, is that sometimes the pronouns are referred, that's referring to a particular name. So for example, here, by choosing Paul Wolfowitz for the post of World Bank President right after he nominated John Bolton, US Ambassador to the United States, President George W. Bush. Now, here, I mean, if you notice that this pronoun, which is referring to president, and this has been, referenced first before even the name itself, okay? So one of them is anaphora, one of them is cataphora. So sometimes you say that, Subrata is giving a webinar, he's focusing on NLP. So there, the pronoun itself is referring to a name that has appeared before, but sometimes it can appear later. And typically, you got to resolve both. And to do some of the applications, that's required. And then structuring is another thing, is as I was telling you, that structuring means in a piece of text can have multiple different types of relations, but extracting general relations is very difficult. But at least what you can do, you can extract subject, verb, and object. But that's also is not always straightforward, because, for example, IBM hires John, and scientists is hired by IBM. They or sorry, should have been John is hired by IBM. So they both convey the same piece of information, but they're different. One is active written and one is passively written. But they can be, there are ways where you can put them into a standard form where you can see that subject, verb, and object. So that's the way you can extract the triples, what we call the subject, verb, and object. So you are guaranteed to extract triples, although extracting relations, general relations, and its values are difficult from a piece of text, but you can always extract. You know that a sentence is comprised of one or more clauses, and then clause must have a verb and subject and object. So there you can at least structure to some extent using subject, verb, and object. So with that, I'm going to give a quick demo of the first part, and then I'll focus on the next part. So what I'm going to do is I'm going to take here. So this a text analytics tool. By the way, there's a list of tools that I'll go through. I'll mention that because there are lots of Python-based tools. There are lots of ready packages, but this is my own package. And here I'm going to open a corpus, and a corpus could be a set of documents, and a document is a very general term because it could be an email, it could be a review, it could be a chat. So as long as there is some text in it, we call it a document. And obviously our objective is to extract insights out of a corpus. So I'm loading a general corpus. This is not a homogeneous corpus. It's not a set of reviews. It's just a bunch of corpus that I have. Sorry, bunch of documents that I have collected myself just to demo different aspects. So, for example, this one is a document that has got 4 sentences, and each sentence is a clause. It's not a complex sentence, so there's only one clause. And then what you can do is for example, the first thing we can do is see the POS tagging. So you can do using open source tools. So here you see that John has been tagged with a singular noun. It's a proper noun, and then there's some chunking you can do. So like John Smith together is a chunk. So you can do chunking, and you can tag those as well. And one other thing I was telling you that you can do is you can extract what you call you can structure it. So structuring means you see here. I was telling you that you can do at least you can extract what you call the subject, verb, and object from each sentence. At least one. If it is a simple clause, then you can extract even more than one. So for example, here, the first one says that John Smith is a scientist, and then John Smith is a scientist. It's all done, by the way, automatically. And you see here, John Smith is a scientist, and then he hired Subrata. So he hired Subrata, and as you see that he is replaced by John Smith. So that's a Coreference Resolution. And it's all done automatically, by the way. And then third one is Subrata is a friend of Sam. So in the previous one, hired is a verb. So he sees the subject, verb, and object. So similarly here, Subrata is a friend of Sam, and third one is John Smith did not break the pot. And although originally in the sentence it is John, but John is replaced by John Smith. So it's also Coreference Resolution. So you do all of these. And once you have that, there are lots of things you can do. Once you normalize a piece of text, at least as you see here, I can draw a semantic graph, and where subject and objects are the nodes, and then the nodes are subjects and objects, and the arrow between the nodes is the verb. So I have a label that way. So in that way, when I drew these, because this piece of text had this document had 4 sentences, and each is a simple clausal sentence, and so I have 4. So I've extracted 4 triples, subject, verb, and object, and then with those 4 triples, I have formed a graph the way I said, like subjects and objects are the nodes, and then the verb is labeling the edge between them. And then as you see, even in this simple example, is you see that once you look at it, you see that John Smith is a node with 3, outgoing or incoming, outgoing arrows. And I couldn't have done it if I had not done this, Coreference Resolution, because otherwise John Smith would have been a node, he would have been another node, and John would have been another node. So I couldn't have drawn this very nice graph where I see where the focus is. And the focus here is really John Smith, just by looking at the graph, which you have drawn, which you have extracted automatically from the sentence. And you can say that the topic of this particular document is John Smith. By the way, there are other ways we can extract topics. We'll get to that. But in this particular one, at least, just by doing the subject, verb, and object extraction, I can draw a graph where you see the center of the graph is John Smith. So you can say that John Smith is really the topic, of this. And then obviously, it's very meta, but if you look at my bio, for example, there'll be lots of triples. And then in that triple, you can always, extract, you can always get rid of the ones that are peripheral. And then you can find out that there is a node that says Dr. Subrata Das, although I referred myself as Subrata, Dr. Das, and Dr. Subrata Das, and they all normalized into single thing. And because it is normalized, I can get a node that has got lots of outgoing and incoming edge. And immediately I can say that these particular document is really about Dr. Subrata Das. And this has tremendous implications, because once you have that, then you can summarize the documents. For example, I can summarize just by using this graph. I can summarize this. I can summarize the document. Document summarization is another important thing. Is you can summarize the document. So, for example, if I summarize my my bio with 10% of the length and with 2 topics, then you see that Dr. Subrata Das and the company that I used to work are the 2 topics, which makes sense. And then obviously 10% of the summary. And this is extractive summary in the sense that it only takes out a bunch of sentences. And then you can also take out a bunch of clauses and then you can construct. And so whatever you construct will make sense because it's an extractive. But generative summary, where you are introducing new sentences, constructing from the existing ones, is much more difficult. All right. So that's my first part, and then I'm going to go through the second part, which is now the document classification. As I was telling you, that classification and structuring are 2 most important functionalities that one must have. And document classification, one application I was telling you, that how you classify, for example, spam and not spam. And there are lots of things like, in the legal applications, there are many applications in the legal domain for document classifications. So in that, I'm going to go through very quickly the document classification, and then I'll give you a demo as well. First of all, so there are, as I was telling you in the beginning, that the most techniques from traditional ML and deep learning that can be used, or that can be modified to use for text analytics purpose. So document classification, we do classification all the time. We do segmentations using structured data. We do classifications. We're doing all the time clustering, classifications, and some of those techniques, for example, very simple, bag of words techniques called naive Bayesian classifier, k-dependence naive Bayesian classifier, and even the support vector machine. It's very popular. It used to be very popular. That those can be used for classifying documents, and then we also can use LDA, LSA. They have been around for quite a while. They're very robust techniques. Those can be used for unsupervised topic extraction, and I'll give you a very quick example of those. So for supervised, as you know, that we have a bunch of level data, and then what you want to do, you want to build a model. So once you receive documents that are not labeled, so for example, spam and not spam, when they come to your, before they come to your inbox, they go through a process and then they classify as spam, not spam. And so they have built a model by seeing lots and lots of them previously. So how do we do that? That's a supervised classification. And unsupervised is without having the label. Can I classify it's a more difficult problem, but you get the point. I mean, can I classify, for example, a bunch of reviews to a good ones and a bad ones? Yeah, because I don't have the labeled data, which is very difficult sometimes to obtain. Yeah. So let me skip that. One of the things when you are doing computational NLP, you got to take your mind out a little bit in the sense that you think always in terms of vectors, because every piece of text, whether it's a word or a clause or a sentence or a paragraph or even a document, the whole document, they become a point in the space. Yeah, that's what the geometric interpretations always, because most of the time what we do, the techniques that are developed in traditional ML, they have these geometric interpretations because they're easier when you are doing optimizations, then it's easier to draw a graph and see how the things are being optimized. And you have to do the same thing here. We are doing a similar approach. We take every document and then we put them into the space. And the space means they become a point. And then once they become a point, then we can do lots of things in the sense that we can say how two pieces of text are different from each other, how two words are similar to each other, stuff like that. So so this is I'm going to give you another example of how to do, so this classification. So classification, this is a very simple naive Bayesian classifier that we can use. So the problem is very simple. You have a bunch of spams and bunch of hams, which are good ones, and they are real SMS messages. Yeah. So you're dividing into two. One is spam, one is ham, which are good ones. And as you see, the objective underlying is always the same. Like, what are the features? Even in the traditional ML, we always look for features that are relevant. Okay. So in this case, the features are really what are those important words that we should be able to find out that will determine which class a particular piece of text belongs to. So in this case, for example, things like free, congrats, don't miss out, those kind of things are very prevalent in spams. Yeah. But whereas, they have a good night and stuff like that, so those are part of, good messages. So using that, how do we do that? So I'm going to give a demo of the supervised classification, and then let me see. So basically, in the demo that you are going to see, where I'm going to build a model, and this is a very simple model. It's called bag of words. So you will have and the model takes in the form of what we call the naive Bayesian classifier. So it has a parent node, and it has a bunch of it has as many children node as the number of stemmed words that are occurring in the corpus, the whole corpus. So, and then once you build the model, and these represent the strength between the class and those individual features or the words. And then as you see that tree, good, mobile, win, those will have different strengths for different classes. So that's the model we build. The model building is all automatic. And then once you build the model, then we can classify. So I'm going to give you a very quick demo of the same tool. So what I'm going to do is, first of all, I'm going to close it, and then I'm going to open a file that has got some spams and hams messages, some few thousand, yeah. So you need those labeled ones to do the classification. So to build the model and then eventually classification. So this is the file I'm looking for, the spam.xls. That's the Excel file. So I'm going to do that. And then I'm going to take that, select that particular tab, and then the topic is really the type, and I'll explain you in a moment. So once you load it, so you see here, there are, these are the individual messages. So some are spam and some are ham. They're very short, actually. And then if you look at the file, so you will see typically like this. So you have number of topics is 2, and then you have number of stemmed words, which are 7,343 stemmed words. So if you collect all the messages together and you find out the unique words, then you stem them, then you get 7,343. And then what you do typically in a classification, you take certain percentage of it is as training data. So I'm going to build the model using 90% of these 5,572 documents or the SMS messages, and the rest I'm leaving it for test and see how are they performing. Okay, so I apply it, and then I have this, and then I'm going to build the model. So you can build model using different types of modeling techniques, but I'm using only the simplest one just to give you an idea of what's going on. And then, so if you do that, so in the so if you run it, then it builds a model. It says that, look, done building the network with 6,918 children. So it excludes the stop words. So it has about 7,000 children. So the model that I was showing you has about 7,000 children. And then if you do sometime what you do is, it is related to the, to extracting relevant features. Yeah. So sometimes you do the dimension reductions in a traditional ML. So it is very similar to that process. You are excluding, like, do I need all 7,000 children? Because some of them are really, they contribute nothing to the classification. So I'm saying, so mutual information is a way of extracting the relevant features. So if I run it, and you will see that I build the same model with 45 children, okay, without sacrificing my performance. And what is the performance is like? So performance is saying that it's about 85% correct, okay? So, and you see here 85%, that means 477 out of 558 I have classified correctly, and this is the confusion matrix, as you know. I mean, that tells you what percentage and in which class you got it right and which class you got it wrong. And another thing I want to show you, that because it's always a bag of tricks analytics. So if you say that, okay, you might say, Subrata, you have done only the naive Bayes, and how about suppose a little bit more powerful technique? Suppose I do this one, okay, K-dependence NBC, and can we do the same thing? And let's see the performance. So it's a little bit more powerful technique than NBC. So you run it, and if you run it and it uses the same number of children, and then if you cluster it and you see it's a 97%. So even by changing the method, by changing the method, you improve your performance by almost 10%. So the point is that, like traditional ML, there is no unique method. So it all depends on what you require, what's your particular situation. And sometimes NBC is so fast that you cannot afford to have any other method, for a particular context. So depending on the context, depending on the time you have, depending on the data you have to choose the right technique. Okay. So in this case, for example, I used KNBC instead of NBC, and I improved my performance by 10%, substantially actually. All right. So how am I doing with the time? So I'm going to go through very quickly the rest of the slides, and then, so that's the NBC, KNBC, I just did it, and these are just another example. So I just take, so SVM is another classifier that you can use, and then LDA is how do you get the, so if I remember that this one is I was telling you that this one is an unsupervised one. So what happens if I take out all the labels, if I give the bunch of messages into this LDA or latent Dirichlet allocation, there are other unsupervised methods, but this one is one of them. So how do we do that? If we do that, then actually I ran one of the models earlier. I can show you. I don't know if you see it, but this is, in fact, I ran it with saying that give me 2 topics, and you can see that it automatically, by the way, I did not use the label. It's an unsupervised classification technique. So you give a bunch of reviews and say that, hey, come up with a bunch of words and saying that, see, this one has got free at the top. As you see here, free at the top. And this one has got something else good at the top. So you see, in an unsupervised manner, you can classify a set of documents into a bunch of classes. So, okay. So with that, I'm going to go through very quickly the rest of the slides. So LDA and LSA is another methods in an unsupervised manner. You can classify documents, and then I'm not going through this example again. One of the things is that the deep learnings are being used a lot lately, and that could be another whole lecture on that. But I'm going to give you some idea of where the state of the art is instead of going through any particular one. So there are many, as I was telling you, that the trend has always been is to reuse the traditional ML and DL techniques. So here are some of the techniques that are being used. I'll show you some of the examples. What are the applications are being used for? So stacked autoencoder, recursive neural net with a long short-term memory, and bidirectional autoencoder. So these are some of the latest and greatest that are being used. And what are they being used for? Is I'm going to show you that one of the things is you must know that I was telling you that we have to think in terms of putting everything, like the terms or documents or the sentences or paragraphs, in the space. So every of those individual terms or documents or paragraph, they become a point. And then semantically, you can correlate, like, for example, Poland and Warsaw, and Poland, Germany, France, because they all are kind of countries, so they are on this similar, close to each other, and they are capitals, and the directions between them are very similar to each other. So semantically, they become very similar things. So here, things like, so that's the word to pick. That means putting piece of text into this space, because once you have a numerical representation of a word or phrase or a document or sentence, then you can do a lot of things. Okay, you can compute the semantic distance between them, and then you can cluster but fundamentally you're putting them. And then another thing you can do is that because words, the sentences are by definition sequential in nature, because sequences matter. So we have been applying deep learning techniques, especially recursive neural net and LSTM, and so we can do things like language translation where sequence matters. Then we can do captioning where you put an image, and then an image will have different types of captions. So you train the model, and then you can generate captions given an image. Yeah. So those are and then business applications. Some of the applications are very hot. Is that like in the legal space, you can do contract verification, legal document classification, relevant versus not relevant, extracting frequently asked questions, extracting topics in consumer chats, image captioning, correlating sentiment and stock price, call center chat classification, extracting feature for customers, segmentations and promotions. All of these, for all of these, you require what you call the fundamental capabilities. Remember that the first slide I show you different, the sequential process of natural language processing, and there were some core functionalities that you require to build these. So classification, summarization, the NL2 SQL queries translation, and then translation from one language to another language. So all of these you require to build these applications. So there are some fundamental core capabilities that you require, And using those core capabilities, you should be able to build, some of the business applications. So I think I'm kind of over time, so I'm going to go. So these are some of the tools, and you can use Python. Python has a large number of libraries. And there are several off-the-shelf commercial tools as well. But with that, I think I skip everything and I leave here. And to you, Anjali.
Thank you so much, Subrata. This is Jahaira. This was a great presentation, very informative. Many people really want to get a hold of your slides and the recording, so that's great. Now we're gonna go into the Q&A section. We are gonna stay a little bit past 4 so that we can address some of the questions, maybe 5 to 10 minutes.
Sure, I'm here, yeah.
Okay, great. So I want to start with, yes, I think there was a question around tokenization, and I think people want to understand a little bit better what are the pre-processing stages before processing this data through a neural network or any other approach, starting from tokenization until word to vector and things like this. Could you go over that process a little bit?
Yeah, word to vec, the one I was telling you, like putting that requires a lot more this thing, because these are trained. These are called, deep stacked autoencoder and decoder, and you don't need to do it because Google has a pre-trained model that you can make use, where you can put a term or a phrase or a document, then you get a corresponding 300 or 200 dimensional vector representation, numeric representation. So those you don't need to do it. You can, because GenSim, I think Python GenSim has a library, so you can make use of that. But that's a very involved process. You don't want to do that because they're probably trained for a week or something, on very fast machines, multiple cores, multiple clusters, and then and these are, very difficult. But
right.
You have a pre-trained model. But what you are asking is this one.
Yeah, I think the question is more about how do you transform your data from text? What is the pre-processing that needs to happen before it can actually be used on a model?
Right. So this is what that's what I was telling you, that it depends on your requirement. So for example, for simple tokenization and stemming, that will let you do the classification. You don't need to do anything else, because classification is really, especially the example I gave, like NVC, it's a bag of words. It doesn't need to have the knowledge or exploitation of the sequential nature of the sentences. So you can do simple tokenization. Like simple tokenization, you can do it using split, for example, in Python. And then Python has a library where you can do stemming, and then you can put it into your classifier. Then you need to know, obviously, how to model. So, and then things like named entity recognition, it requires a little bit more involved, and things like Coreference Resolution, there are other libraries, you don't need those to implement yourselves. The relation extraction, it all depends on what kind of, applications that you want to build. If you are doing spam versus ham classification type, for example, if you have a bunch of documents, for example, if you want to classify them into multiple classes, then if you are using naive Bayesian classifier, then you don't need to do anything more than tokenization and stemming and lemmatization. So does that answer the question?
Okay. Yeah, I think that addresses some of the points. Thank you. Okay. Another question, yeah, so people are asking, could you share like a real world application, and what was the goal of the project? What were some of the trade-offs that you had to consider when deciding what approach to pursue?
Yeah, I mean, obviously, I have to be very careful. I cannot share everything, but here, for example, these are some of the work that I'm doing right now, or just finished doing in the last job. So some, one of the things, we're doing it is in fact, lots of patients are calling with their symptoms. How do you find out what are the things they're asking for, and what are the common set of complaints, and then like in the call center agent, there that thousands of messages. So automatically, can you find out what are the most complaining about? And then sometimes you have this promotional thing. So you want to classify your segment, your customers into different buckets, where top customers, medium customers, low customers. And in those places, the sentiment of the customer, for example, if the customer is angry, you might want to put some additional, promotion, those kind of things. It requires, analyzing the sentiment and then extracting features, these are like I did, for example, one of my previous assignment was to do the contract reviews. So, a legal company, receives lots of contracts every day. So they want to find out. So they have some standard requirements. So certain clauses have to be present. So they want to find out, given a contract, what are the clauses that are missing? What are the clauses that have been added? And what are the clauses that are, satisfying their requirement? So basically, those are more difficult in the sense that you are extracting, you take a contract, then you divide into paragraph, and then each paragraph you compute the distance between that paragraph and the given required paragraph, and then you find out whether those are new or those are almost similar to the ones that we require, or something is missing in it. And then we also did things like classification, for example. In a typical legal company, they deal with lots of cases. So if a company is involved, so they have to hand over every document from the company. So, but they don't want to hand over everything. But some are relevant, some are not relevant to the cases. So we classified into relevant, not relevant, to all the emails and internal documents, everything. So these are some of the examples. And then obviously, done a bunch of projects on captioning, which are hybrid of image and text and structured data.
Right.
Right. So these are some of the examples.
Right. Okay. Thank you for that. There's a couple of questions that I'll summarize with what is the best way to get started with NLP in terms of resources, courses, books, tools. And there's also another question about which Java application you were using to create the models. So if we can address those, that'll be great.
Which Java application? So last one.
Which Java application do you
Java
use
application
to make to build the models?
Oh, okay. I would suggest that, the one I was using is my own tool. I mean, it's very powerful tool. This one has got, classify documents. You can analyze sentiments. You can do social network analysis, triple extraction, document summarization. But this is different. But I would suggest, because this is my own tool, but there are tools, there are free tools. For example, if you're a Python programmer, there are many libraries. And in fact, I gave you, I think, a list here. I think I gave a list here. Yeah. So you can use NLTK, GenSim, Scikit, Keras and TensorFlow if you're getting into the deep learning. So these tools will be very good for you to get started. For example, NLTK has all the capabilities that you require. You require tokenization, stemming, what to make representation, one-hot encoding, those kind of things. So those. So I would suggest before even you jump into any paid to go to Python or even R, because all the tools are available in R as well. So you start using Python or R, and in that context, I would say just start with some simple practical applications like classification or even some of the other things like search. You know.
Yeah, great. Yeah, I'll add to that. If you guys do like a Google search of like NLP, there's this blog called Towards Data Science that gives you like a lot of resources and steps on what NLP is about, and in a very simple way to understand. So that could be a
Right.
good resource to look up, and leverages some of the tools that Subrata just mentioned, like Python and scikit-learn.
Right. Right. And there are tons of, but you have to be careful though, because there's a lot of hype around NLP. Because even when you talk to Alexa or Google Talk, or I mean, I have to be careful what I say. But I'm just saying that if you ask them a complex question, complex in terms of the sentence structure, then they will send you to web, saying I have found these articles for you or something, because that means they're not able to parse it. So we have made tremendous progress in the areas of translation, probably captioning, but we still have a long way to go.
Right. Yeah. So there's a very cool question here about, I'm just going to read it because I like how it's phrased. So which tech company do you think will be at the forefront of the race towards producing NLP and machine learning products? Yeah.
I cannot be biased. I think it's I don't know. I refrain myself from answering that. But one thing I assure you that the way it is projected, the state of the art, it is not as rosy as it looks. It's because we have a long way to go.
Okay, thank you for that. There's another question about what percentage is unstructured data versus structured data.
It used to be like more than 80% people used to say that, but maybe because if you consider like the images, videos, they're all part of this, the audio, all part of this unstructured thing, then it's huge, because even the social media, the amount they produce, is kind of mind-boggling. But we don't produce, because a lot of the time, we just make use of the metadata, because nowadays you see that when you search images, when you give, they make use most of the time they make use of the metadata. That means the data that's attached to. So you do textual search, and see if it matches to your query. But now we started doing the actual search, in the sense that you give an image, they find out similar images. In the context of text, in fact, it is even more difficult, in the sense that when you specify a bunch of keywords, and you and I specify maybe similar set of keywords, but our intent is maybe totally different. So understanding intent is the most difficult. And sometimes that's why they go and look at what you have searched before, and so on, and your background, stuff like that. And then they try to give you the most relevant set of documents, or retrieve most relevant set of documents. But in terms of division of unstructured and structured content, it's tough to, I don't have any statistics at this stage. I used to have a long time ago, but not anymore.
Probably has changed, yeah. Okay, so we are running out of time, so we won't be able to get to all of the questions. I'm sorry for the ones that are gonna go unanswered, but we do wanna get to one question to close this up, and that's how can we leverage NLP right now in the midst of this global pandemic? Or how is it being leveraged right now?
Oh, it's absolutely. I mean, in fact, I gave a project. I'm myself involved in COVID-related project, by the way. Dealing with patients' queries and stuff like that. But then also I gave, for example, an example and a project to Northeastern. The relating, the frequency of tweeters. How can we extract a feature, for example, as frequency of Twitter or even the content of the Twitter to understand the pandemic or the nature of the epidemic of that particular region. Yeah. So there's a lot of things you can do. In fact, understanding the unstructured data, what people are talking about, sometimes they talk openly and also mostly because I know that the company I'm working with, they're flooded with queries and lots of queries and because it is all of a sudden, so there's obviously, a computational approach or an automated approach of understanding what is the most serious situation, what are the most complaining about, are extremely helpful. Yeah.
Cool. So we're actually gonna be kicked out of the Zoom meeting in 1 minute. So we wanna thank Subrata for giving this amazing presentation and everybody that attended. Thank you for your questions. And we wanna remind you too that this is a series. So there will be other events with topics regarding machine learning and artificial intelligence. So we hope you can join us.
And they can contact me if they have really a question. I'll be wearing my academic hat and I'll answer those questions. Yeah.
Great. Yeah. So here's Subrata information. So feel free to email him if you didn't get your answer addressed today. And have a great day.
Thank you.
Bye.
Thank you.